Okay, we're going to solve a few problems here involving rational exponents and nth roots. Our first problem that we have is the square root of 16x to the fourth y to the third over x to the 2/3 y squared. So the first thing I'm going to do is rewrite this entire expression here without this radical. So let's write 16x to the fourth y to the 2/3 over x to the 2/3 y squared. And instead of the radical, what I'm going to do is write a set of parentheses. And we do know that taking the square root of something is the same as raising it to the 1/2 power. Therefore, all the terms inside this parentheses are going to be raised to the 1/2 power. So I'm going to rewrite this once again as 16 to the 1/2 power, x to the fourth to the 1/2 power, y to the 2/3 to the 1/2 power over x to the 2/3 to the 1/2 power, and finally y squared to the 1/2 power. All right, now what we're going to do is raise all these terms to the 1/2 power. The first one is going to be 16 to the 1/2 power, and that is going to be equivalent to taking the square root of 16. So 16 to the 1/2 power is simply going to be a 4. To do x to the fourth to the 1/2 power, what I'm going to do for the rest of the terms is multiply the exponents. So we're going to have x 4 times 1/2 is what I'll write here, 4 times 1/2. And then y to the 2/3 times 1/2 over x to the 2/3 times 1/2. And finally, y squared times 1/2. Now let's go ahead and multiply all of these exponents here. So the 4 still remains, and what we're going to have is x. 4 times 1/2 is simply 2. 2/3 times 1/2, these 2's can cancel each other out, and what we're going to be left with is y to the 1/3 power over, same thing is going to happen here, and we'll have x to the 1/3 power, and same thing here, and we'll simply have y. Now, our next step is going to be to subtract the exponents that are in the denominator from the ones that are here in the numerator. So we're going to write 4 times x to the 2 minus 1/3, and then y to the 1/3 minus, there's an exponent of 1 here, an assumed exponent of 1. All right, let's scroll down a little bit and continue. So we still have our 4, and 2 minus 1/3, we can think of the 2 as 6 over 3, so 6 over 3 minus 1 over 3 is 5 over 3. 1 over 3 minus, we can think of this as 3 over 3. So 1 over 3 minus 3 over 3 is going to give us a negative 2/3 power. All right, next up, what we'll do is this exponent here is negative, so it's going to have to move to the denominator of this term. So let's write 4 times x to the 5/3 power over y to the positive 2/3 power. All right, and the expression is now simplified. 4 times x to the 5/3 power over y to the 2/3 power. This can also be written like so. Let's write the 4. And x to the 5/3 can be written as x to the 5 times 1/3 power. Y to the 2/3 can be written as y to the 2 times 1/3 power. And what this means is we can write the 4 is going to stay the same. We're going to write the cube root of x to the 5th over the cube root of y squared. So this expression and this expression are equivalent. Okay, next up, what we have is the 7th root of x squared times the 4th root of x. First thing we'll do is rewrite these in exponential form. Therefore, what we're going to have is x squared, and we're going to drop this radical here, write it in parentheses. Taking the 7th root of something is equivalent to raising it to the 1/7 power. And that's going to be multiplied by, we'll write another set of parentheses. In this side of the parentheses, we're going to write an x. Taking the 4th root of something is equivalent to raising it to the 1/4 power. Okay, our next step will be to multiply these two exponents here. So what we're going to have is x. This is essentially 2 over 1, and 2 over 1 times 1 over 7 is 2 over 7. And we'll multiply that by x to the 1/4 power. Since these have the same base, what we'll wind up doing is adding these exponents here. So we're going to have x to the 2/7 plus 1 over 4. And we can't add these exponents the way they are right now. So what we'll need is a common denominator, and the common denominator of 7 and 4 is going to be 28. So it's going to be x to make this, write this so that it has a denominator of 28, what we'll have to do is multiply the top and the bottom by 4. So we're going to get 8 over 28. And to rewrite this so that it has a denominator of 28, we're going to multiply the top and the bottom by 7. So what we'll write is 7 over 28. And now we can add these up. So we'll get x to the 15 over 28 power. Okay, next up, our last example, we have the 4th root of w cubed times the 3rd root of w. And once again, we will rewrite this, dropping the radicals. So let's write in parentheses, w cubed, taking the 4th root is raising it to the 1/4 power, times w to the 1/3 power. Similar to before, what we'll do is multiply these exponents here. So we'll wind up with w to the 3/4 power times w to the 1/3 power. And what we must do next is add the exponents. So because the bases are the same, so we're going to have w to the 3/4 plus 1/3 power. And we can't add up the fractions the way they are right now because they have different denominators. So the least common denominator of 4 and 3 will be 12. So we'll have to rewrite both so that they have denominators of 12. in order to rewrite this so that it has a denominator of 12, we have to multiply the top and the bottom by 4, which is going to, multiply by 3, which will give us 9 over 12. And we multiply the top and the bottom here by 4, which gives us 4 over 12. So what we're going to wind up with is W to the 13/12 power. And there we have the 3 examples using rational exponents and nth roots.